and welcome you to physics class today. We are looking at Ohm's law. Let's define Ohm's law first. Ohm's law states that the potential difference across the ends of a metallic conductor is proportional to the current flowing in the conductor, provided temperature and other factors remain the same, meaning that they are constant. What am I saying? Let's look at so for Ohm's law to be actually to be carried out, we have this circuit on the board, which of course we have discussed some of the circuit components before now. I have my power supply, the battery, connected with the variable resistor, which we also refer to as a rheostat. We have our components that we want to use to verify the Ohm's law, which is the resistor, and across the end is the voltmeter, which measures the potential difference, and of course the ammeter measures the current. Now, before I have a table of value here, which I want to use as my own suggested readings for that law. But let's focus more, first of all, on that law. Let me explain it to you so that you know what I'm talking about. Now, if I have a metallic conductor, as I'm sketching on the board, let's say this is a wire, and across the two ends of my wire, I have a battery across the ends. Okay. Now, let's pick 2 points. What we are saying is that if 2 points is being picked, on the wire, the potential difference across the two ends must be proportional directly to the current that is flowing in that conductor, which we can, put into mathematics. We say that potential difference is V directly proportional to the current flowing. And according to the law of mathematics, this can be taken further to be V equals to IR, where this letter R represents the resistance. And of course, we have our R to be written as obtained as a V divided by I. Okay? And when you talk about units, we say that the potential difference is measured in volts. Measured in volts. The current is measured in amperes. And the constants we are obtaining from this equation, which is the resistance is measured in ohms. Of course, it is from the unit. The name of the unit is what is used to honor the law we are talking about. Okay, and that ohms, the symbol for it is omega symbol. All right. Now, having explained this, there's another thing you have to know when you talk about Ohm's law from the reading we have obtained. Let us take a step further by sketching. I want to plot this graph now, but we have various types of graphs you can plot. But I'm going to focus just on one. Maybe I will allow you to try one at home to enhance your learning. Let's say I want to plot on the y-axis we are plotting V, and on x-axis we are plotting I, which is current. If you look at the reading we have on the board, you can see the value as voltage is increasing this way, also the current also increasing. If we transfer that into graphical form, we are going to have a positive slope graph. Let's say that's my line plotted point. If I find the slope or gradient of my graph, the gradient or slope, ladies and gentlemen, is going to be change in V divided by change in I. Of course, the constant that I'm going to obtain there is what we refer to as the resistance. So what I'm saying is that once you have the values and it's being plotted and you find the slope, the quantity, the constant you're going to get, your slope gives you the resistance for the material that we're actually talking about. Okay, in this case we're talking about the resistor. Alright, so which means the slope is resistance for the material. The another point I want you to also understand is this. Any material like this resistor, for example, that fulfill or obey Ohm's law is what is referred to as ohmic conductor. They are called ohmic conductors. Okay, we have different types. We have copper. Copper wire is ohmic, meaning that it obeys Ohm's law. We can also have nichrome. Nichrome also obeys Ohm's law. The second type, those ones when you have the current and voltage plotted, the graph will not be a straight line. Such material is referred to as non-ohmic conductor. Okay, they are called non-ohmic conductor. Example of such electrolytes. Electrolytes, okay, acid and stuff. Electrolytes. Another example could also be semiconductors. Okay, semiconductors also fun. So these two categories of materials, they are also important, and we need to understand that they exist. So by and large, what we are talking about is Ohm's law, and it's a very important concept in physics, which is the foundation to all and to a less part of topic in physics, which I believe you now understand. So I will see you some other time. Have a nice day.